Yeah. Yeah, hello and very welcome. My name is Wolfgang. Thank you so much. And today I'm going to share a talk with you that shows how to actually Zabbix can be deployed in Kubernetes environments, and in particular in hybrid environments or on-premises environments, and show how that will go. And before I start with the talk and go into the depths of the details, I would like to say thank you to the Deutsche Telekom Technik team because it was still is a great project and was a good experience to work together. So let's start simple. Maybe who has already used Zabbix with Docker? Maybe, okay, quite a few people. Who is doing this in production? Okay, yeah, wonderful. That is how the Docker command line would look like, very basic stuff. And we can pass some params in the sense of environment variables to the container. We can use Docker Compose, which makes the stuff even easier. So that is how it looks in Docker, in a container technology most of us are familiar with. Now let's have a look in how we can do the same stuff with Kubernetes. And in fact, Kubernetes is also using container technology. Those of you who follow the development of Kubernetes know the change that they shift to containerd, etc. But at the end of the day, it's a container technology. And we have basically two options here. So option number one is that we can use Kubernetes in the same way we use Docker. So we write some YAML configuration files and we pass them over to kube control and then we will execute the stuff. Or we can use configuration and template management, and that is available to Kubernetes and it's called Helm. Helm is a package manager for Kubernetes. It provides config repository structures and template systems. And what you can do then is, if you have complex applications, like for example with Zabbix, we would require a database, a front-end server, and the Zabbix server, of course, itself. Then you can bundle these configurations, what is then called a Helm release. And this gives us consistent upgrades and versioning. The slide here shows two links. One you can use if you would like to use Zabbix to actually monitor your Kubernetes environment. And the other one is if you would like to do a deployment. And I think one of the guys here, Christian, is also part of the team who is actually deploying or co-maintaining the new repository on GitHub that moves from the static repository to the community repository. So thank you for the effort you are doing there. So what is Helm? Basically, Helm uses a template, a configuration template on one hand, and values that are being used in such a template. And the nice part of it is that you can actually create some default values file out of an existing Helm configuration template. That's really nice. And okay, at the end of the day, you then have to set the params and the value files, and you're to go. So if someone is asking what values do I have to fill in and what values or what type of values needs to be filled in, that's basically depending on the person who has created the template configuration. Very similar to Zabbix. So when I would like to use this technology in Kubernetes, which we are most likely want to do, then we would have to add an Helm repository. Then we have to update the Helm configuration with the new repository. Then we would create, I think there's a laser pointer here, yeah. And then we would create this empty or the default values file for the Helm templates involved in this configuration. And then we make the changes that are required to actually deploy our Zabbix instance. In this case, we would like to use an external database. So we say enabled false, and then we pass our credentials here. So that's what's happening here. And after we do an Helm install here, at the upper part of the screen, the application should be deployed and everything goes fine. Then the applications in the Kubernetes cluster gets deployed and we get this one here, which is good. And after the deployment process happens, we can start and have a look to the log files in the Kubernetes cluster for our pods to see whether they are doing what we expect them to do. In our case, we expect the database to be created and the Zabbix server to start. And it seems to work. And this is a tool, a graphical tool called Lens, where you can have a view on the Kubernetes cluster and use this to make screenshots here. So it's maybe better to see and understand if you're not used to this technology that much. So we have here our pods running containers, and we see the environment params passed to that container and so forth. So finally, the installation is there. Now, if you do this type of deployments in Kubernetes, and it's not only affecting Zabbix, but any application you would like to deploy in Kubernetes, and that should be accessible via the network, then at some time and point you must think about how you make your application accessible from the outside network-wise. And the problem here is that if you're using HTTP-based services, then HTTP-based services can be made quite easily accessible from the outside using reverse proxies, like an Nginx proxy, like a traffic proxy, whatever you prefer to use. If this is non-HTTP-based traffic, like UDP or TCP ports, in our case, the Zabbix Trapper port, 10,051, then these cannot be easily routed. They require usually a dedicated IP address or a dedicated port. And if you're using cloud services, AWS, Azure, and so forth, they usually provide you with some technology behind the scenes, so you don't have to take care on yourself if you would like to implement this. And the question is, how can we use or solve this issue in our cloud, in our hosted cloud environment, in our self-hosted environment? And one solution, there are others out, but one solution, the one that we picked up, is to use MetalLB. MetalLB is a layer 2 network load balancer and does exactly what we're looking for. It allows you to predefine a pool of IP addresses, can be IPv4 and v6 addresses, and then this pool can be used in a similar way as a DHCP pool would be used. And this allows us to make our service available to the outside. So here we see how we actually deploy our MetalLB service in the Kubernetes cluster, so it will be available within the cluster. And using the same technology, we're using Helm and so on. Then we make changes to our Zabbix deployment here. So we changed the service type that it now will become load balancer, and that it use the port 10,051, and this is a node port which is mapped into the service. And after we make an upgrade to the Zabbix deployment we already did previously, with the change to use MetalLB, we see now that we have here in our overview an external IP address assigned to. This is the external IP address assigned from MetalLB. So mission accomplished. We can access Zabbix now from outside the cluster. Okay, so what I've tried doing so is to give a quick introduction in how Kubernetes works in general, how you can make a deployment, and how it would look like, taking Zabbix as an example. So what are the real-world challenges from my perspective, or from our perspective at least? So when installing applications like this in a Kubernetes cluster, the one challenge is the lack of experience. So how do you do the steps? How do they interact with each other? What is a node port? What is a service port? Where do I get the Helm charts from? Are they really working? And so forth. Another issue is we need to ensure consistent application configurations. I mean, what we finally do is we set up a configuration and define a state that we would like to accomplish. And then the magic should happen and should create that state. So we would like to manage configuration changes. We would have to find a way to manage password secrets and configuration files. You remember I put this password for the Zabbix database in clear text, so how can we address this one? And we need to find building blocks to find a more user-friendly approach. And one building block is Flux. It's one of the core building blocks, and Flux allows to manage and apply configuration changes in Kubernetes cluster. You find the URL here the bottom of the page. So what does Flux offers you? Flux offers some sort of a GitOps solution for Kubernetes. And this enables us with proper versioning, with easy rollbacks, and with consistent config states. Flux itself is installed in a Kubernetes cluster, and what it does, it watches one or more Git repositories, application Git repositories with application metadata, and then takes care of the deployment process or the update process, and it's using the Kubernetes API, so no shared files involved, etc. So that is one important component in our build chain here. So how does it work? We have our image repository, where we, for example, would find the Zabbix MySQL server image, the front-end image, etc. We have our Helm registry with the Helm charts. We have our Flux Git repository. That is a Flux Git repository Flux uses to, have all the information required to do its work within the cluster. And then we have for each application, or for each application deployment maybe, that's the design decision, we have our individual Git repositories. And what happens then is that our DevOps team makes commits to those repositories, and then Flux does its work, pick up the information from the Git repository, executes via Kubernetes API the necessary steps in our cluster, and if all things work well, then the application gets deployed in Kubernetes. The next building block I would like to introduce is Zabbix. And Zabbix is a tool to manage and apply secrets. And we need a lot of secrets, like database secrets, like API secrets, and so forth. And then you can say, yes, we can encrypt the secrets. Yeah, fair enough. But the deployed application somehow needs still to decrypt the secrets. Then there are Kubernetes secrets, for example. We have vaults. But at the end of the day, at some time and point, you need to pass keys and access to decode those secrets. So it's some sort of chicken and egg problem here. And in some cases, it might be that multiple users have to have access to those secrets. Like, for example, you have a DevOps team with like 4 people or 5 people working in it, then each of them should be able to make a change to a password, or to at least change the configuration for the password. So how would that work out? And Mozilla, the Mozilla Foundation, the Mozilla browser maybe, the Firefox browser, and they have other projects. They created SOPs, secrets operations, exactly for that use case, for their own use. That is what they did. So that is a development they made open source, and they did it just for this particular use case. And it's really smart and it's really clever. And I'm just taking the time here to explain it to you. But first of all, what does it provide? So SOPs gives you basically what SOPs allows you to do. It allows you to encrypt any text file, usually configuration files. In our case here, it's a YAML configuration file. So it allows you to encrypt content in such a file in a way that it can be that it still stays a text file, because they encrypt the stuff and then encode it into special base 64 strings, which is perfectly fine for a text file. And what they do is they add then meta information here. This is all added meta information to inform SOPs how this critical information has been encrypted and how you can decrypt it again. And they have native support for different encryption provider. Like, for example, they support HashiCorp Vault, they support AWS KMS, Azure Key Vault, GCP KMS, PGP, so different provider can be used. So it's very, very flexible. I really encourage you, visit the website, it's cool stuff. But for our purpose, let's have a look of how it would work in practice. So let's say we have a file, credentials.yaml with 2 keys. It's a YAML configuration file here with 2 keys. And we would like to encrypt this stuff. Then we say sops-e that will perform the encryption. And then SOPs will create a file, which is this one here. You see it's much longer. And we see here that this information, our keys, are now encrypted with meta information. We see here that we have a type of encryption, and we see here that we have, and here we see one encrypted master key block for one reception. And this master key block is encrypted with a public key provided earlier for this particular user. And if that user would decrypt this block here, this user would get access to the key that is used to actually decrypt the values over there. That is what's happening here. A more complex example looks like this. In this case, we have, again, a couple of keys. Not all keys are now encrypted, just some of them. So for example, the polar definition here, we leave that information unencrypted because it would not add any value if you would encrypt it. So it's much better readable. And now we see we have two different receptions defined here. So what we have basically done during the SOPs encryption process, we took two public keys from two different users, and SOPs created their personal encrypted package here. So each of these users can now decrypt the value, the master key, and therefore the value of this file there. I need to speed a little bit up. Just figured out here that the slide number and the remaining time are not in a good position to each other. So that is our block SOPs that handles the encryption. And finally, and that is something that we developed for that project, is Cloud Deploy. And let's ask ChatGPT upfront what is Cloud Deploy. And ChatGPT will answer something like Cloud Deploy is not a specific term of technology, rather it is a broad concept that refers to the process of deploying application or services in cloud infrastructure, which is the intention of Cloud Deploy. So how does Cloud Deploy works under the hood? And keep all the slides and all the details that I mentioned to you earlier, please keep them in mind. So how does it work? We have here our Cloud Deploy provisioning server, and Cloud Deploy also provides a database or has access to a database provider, so we can work with internal databases, but also with external managed databases. In this concrete scenario, we are using external managed database because there's an entire DBA team behind that. They take care of clustering, they take care of backups, and so forth. Then we have here our Kubernetes cluster, we have our Flux component again, and we have our Git repository based on GitLab in this scenario, but can be anything, could also be GitHub or whatever you would like to use, or Git-tier. And then we're using Ansible and Ansible playbooks to execute actions from Cloud Deploy to that repository. And these actions, you remember that anything that's happening here on this side is reflected by a configuration change in the Git repository. So all we do is now we use Cloud Deploy and Ansible to somehow manage our Git commits and makes the life easier for the users or for the administrators. So another point from Cloud Deploy is that it has a variety of access possibilities. So we can access via a front end, we can access using APIs, and also there's a Terraform provider available, which I will show in a minute. And on the other hand, we can work with single sign-on identity providers. In this case, for example, Keycloak. It has then roles mappings available, but these are nifty details which are not so important right now. So if Cloud Deploy would like to initiate such a process to, create a new Zabbix installation, so what it does is Cloud Deploy uses Ansible playbooks and creates the necessary information in various Git repositories. It uses the GitLab API basically to create new repositories if these repositories are required. We have two repository types for each application. One is a system repository and the other one is a user repository. The idea is here that we have settings that are defined by the final super administrator of the service who doesn't want the user to change, for example, the database settings, but we would like the user to change the polar settings, which are no longer required in Zabbix 7 because of autoscaling, as I understood. And and the next one then is that those configuration files will be created for Helm. The environment files will be created, the defaults will be created. This new application will be then registered to Flux in the Flux repository. And finally, Flux will then pick up the task of configuration and will start the deployment in Kubernetes, very similar to what we have seen earlier in the slides, which I did manually with Helm install or with Helm update. This is how such an config registration looks like. Yeah. So, for example, here register the Zabbix system Git repository in Flux. That is the Flux. This is Flux directory, and what you can see here is that we tell Flux there's a new repository, and this new repository is the system application repository, so Flux knows about it. And what we can see here in the customization object created for Flux, we also see that Flux knows that there is a provider called SOPs, and that this provider is to be used to decode the coded information in our configuration files. This is just a very simple view to show how the application directory and the system directory look from a user perspective. Just two directories here, two Git repositories. I'm sorry, not directories, but Git repositories that are automatically created. And this one here is now showing how the Helm release that is created by Cloud Deploy based on our previous information looks like. This is just a configuration file. It's pretty much the same that we saw manually before. And again, you can see here that, for example, the database password is encrypted using SOPs. And because Flux is aware of SOPs, they can decrypt this one. And also can any of the authorized persons make changes to the configuration document, and it will still work. This one shows how the user can make changes to the configuration by just setting environment vars. And finally, if everything is deployed properly, if the dust has settled, so to say, then we should see that we have a new service definition here. We have our pods, Zabbix server with agent and Zabbix front-end pod. MetalLB has assigned the IP address, which is available from the outside. The Ingress, the Nginx Ingress reverse proxy has assigned the URL slug. And yeah, so we can now access the entire Zabbix installation from outside. How does all of this look from the user perspective? So we have seen what the details are, how we can do it manually. We have seen that, Cloud Deploy would give some assistance here. So how does this process to actually create any new Zabbix installation from the user perspective? Well, we can use the web-based portal, and the web-based portal has what is called a service template. So pretty much to Zabbix templates, we have service templates, and based on the service template, a service is created, and each service template provides what are provisioning actions, like for example, create is a provisioning action, delete is a provisioning action, and each action then can have different tasks. And that is how it looks like. So we have a template definition here to provide a Zabbix 6.0 instance. And the actions defined for this instance are update, create, and delete. These are update, delete. These are the screenshots of the update, delete, and so forth actions with their individual steps. And these steps can be, for example, Ansible playbooks that are being executed, and each step then each task can then have their own configuration depending on the playbook that's being executed. So, for example, if you would like to have a notification via email or via Jira, or you would like to open a ticket like check whether the new deployed instance is working, it's just a matter of adding a step here in the task list. So from the user perspective, it looks like step number 1, select a template. Step number 2, give your Zabbix installation a name. That's called your factory name, which name you would like to use. Then you can make a choice for the size, and we pick up a proper database from the pre-configured database provider pool, and you define a slug and a GitHub user, and then the process starts rolling. It will be executed. The provisioning steps will be executed and will be streamed in real time to the customer or to the user, so we can see immediately whether that step worked or failed. And if everything goes fine, then if everything goes fine, yeah, it goes fine, then finally you should have your Zabbix front end available. You should see in your Kubernetes monitoring that the new pod is deployed and everything is there. I mentioned on the internals of Cloud Deploy that we also have APIs available. In fact, we have a REST-like HTTP API, we have a gRPC API, and we have Terraform provider. May I ask, just because of curiosity, anyone knows Terraform or has used it? Okay, a couple of people, great. Yeah. So this is documentation for the REST-like API. We are using the Open API specification, which, for example, allows you to use tools like Swagger to immediately play with the API. So it's not just documented, but you can do it in, can do it with data structures. This is how the Terraform provider looks like. So you register our Cloud Deploy as a Terraform provider in the first step. And this is, for example, the definition for creating a new Zabbix instance. And it's basically the same information that you provide via Terraform that you have seen on the interactive web user portal. You select a template, you define a name, optional you can have a description, and then you have some meta info, like, for example, Zabbix small is a predefined configuration item to select a proper database. And then it will start going. And then you do Terraform apply, and it will start the deployment process. Because it's asynchronous, we do not wait and block until the process finished, because it can take some time, depending on the environment. So it really allows you, it gives you the current job state back, and then you can use Terraform refresh. Those hands up will know this command very well. And then you can query the state, and it will give you immediately feedback where it currently is. And finally, we see small status equals ready, and that means that the deployment has been finished. Yeah, finally, in this project, it was important that all of these instances that have been created by this mechanism in here, that they are somehow monitored. And of course, we're using Zabbix to monitor the installations created, so one to rule them all. You remember that quite a while ago, Zabbix allows to access internal metrics from one Zabbix server to another Zabbix server. So we have here our Zabbix instances that are deployed via Cloud Deploy. We have here our master Zabbix server, and the deployment process then triggers some work under the hood. For example, the Cloud Deploy API allows or works pretty well together with low-level discovery. So we can use LLD in Cloud Deploy to actually discover them on the central instance and then create hosts and host prototypes and work from there. That's pretty fun. Also, we automatically create for each installed Zabbix instance a service definition in Zabbix, a Zabbix service. And we extended the service definitions a little bit in a way that you have a graphical representation about how the service setup looks like, and that's being created for any Zabbix instance deployed. And here we can see on the central master server the list of Zabbix installations created all by Cloud Deploy. And here, finally, we see the health of all those machines using this new widget stuff from you. Which has been implemented. Yeah, I have to say, this one is all compatible to Zabbix 6.0. There's a lot more under the hood, like, for example, we're creating automatically dashboards because some features were not available in Zabbix 6.0 LTS, but in 6.2 and 6.4. So, yeah. I did it in time. Thank you. Thank you so much.